Hello everybody. Welcome back to another session on Python programming. We're discussing a very important concept of functions. In the last session, we talked about a very interesting concept called as local or nested functions and closures. Today, we're going to take the discussion further. We'll go beyond closures and understand a new concept called as non-local. Earlier, we had learned concept of global variables and local variables. Today, we'll look at non-local variables. What exactly do you mean by those things? So what we had covered up earlier was this concept of closures. Just let's go through the term closure once again. So it is a nested function, a function which has been defined inside another function. But then there are a few things. The inner function remembers the state of the variables of the outer function. That means when that inner function was called or returned, it remembers when the outer function was called, what were the value of the variables of the outermost function. Remember the times function that we had taken. So whenever you have a nested function and the outer function returns the inner function, and inner function accesses the variable of the surrounding environment, that's called as closure. So those things we have seen. So closure is a function that's defined inside another function. So it's a nested function, but it is then passed outside that function where it can be used by other code. So we have a function returning a function. So that was the basic idea. The closure occurs when the function has access to the local variables from the enclosing scope that has finished execution. So the outer function which has currently finished execution, the inner function, the nested function which has been returned, remembers the state of the variables of the enclosing function. So that creates a closure. So today we'll take the discussion further on this concept of closure. So nested function can reference variables in the enclosing function scope even if that function is already returned. That means you call the outer function execution has got over, and the outer function has returned as instead of value, it has returned a function. And the inner function which has got returned, that is remembering the state of the variables of the outer function. We can also change this such enclosing scope variables as long as we need to declare them non-local variables. Now, what do you mean by changing the scope of such enclosing variables as long as that we declare them as non-local statement? With this statement, the nested defs can have read and write access to the names in the enclosing function. That means it can go ahead accessing the variables of the enclosing function. It can read it as well as it can write. So Python 3 introduced this new concept of non-local, which has meaning only inside a function. That means it is not global, it is not local, but it is in the surrounding environment. That means the inner function, it's not within the scope of the inner function. It is not global. It is outside the inner function, but inside the outer function. That becomes non-local. So if there is a function, if I say non-local name, that's also okay. But if I just want to create a non-local variable outside, that would generate an error. Non-local causes search for the names listed in the statements to begin in the enclosing def scope, not in the local scope of the declaring function. That means inside a function, if I define any variable as non-local, it will not search for the variable within that function. It will search for the variable in the surrounding scope, not within the function in which it has been declared as non-local. The name listed in a non-local must be previously defined in the enclosing def, where non-local is reached, the error is encountered. What is it? A name listed in non-local must have been previously defined in the enclosing def. When the non-local is reached or an error is reached, that means either you should get it in the surrounding scope or it will not be, it will generate an error. Non-local is strict. Scope search is restricted only to the enclosing def. Now there's too much of it, but I'll give very good examples to understand this concept. A non-local statement tells the Python that the listed variable is in some parent scope, and that the assignment to non-local variable will rebind the variable's value instead of creating a new variable in the current scope. Remember the concept of global variable? If I assign a value to a variable inside a function, even if it was declared global, it created a new local variable. To avoid that, we had a statement called as global. Now, the moment you use that statement called as global, we are telling the function, please do not create a new variable. Although if I'm assigning value to it, use the variable that has been defined in the topmost level. That was global statement. Likewise, non-local will restrict the nested function from creating a new variable. Or rather, we will say, please use the variable which is there in the surrounding scope, not the global, not the local, but the surrounding scope. It is only tricky case. The only tricky case is that non-local will stop before the global frame. In other words, it will not find the variable in the global frame. So let's look at this concept of non-local. We had seen this concept earlier. Now let's look at non-local. This is the one that we had seen for concept of closure last time, the number of times. So if I say multiply by 2, so the factor over here is 2, and this multiply remembers the factor. So this version of this multiply by function, which returns the multiply function, remembers that the value of factor is 2. Whereas later, when I give a call to this multiply by 3, it returns again this multiply function. Look at this function returns multiply. It remembers that the value of factor is now 3 because factor is the variable of the surrounding environment. But I'm only reading the value. I'm not changing the value of the variable. Now let's come to another concept. I have a function called as tester. I have a global variable called as glb_var. That's my global variable. I have a variable which is of the surrounding scope. If this is a nested function, this is the function which is the surrounding scope. That means the nested function is present inside this tester function. The tester function has a variable called as start. It has a variable called as start. Now, in case if I decide to use this global variable inside this function, then I may not define a variable. If I don't define a variable, and if I say global variable, it will use the variable of the surrounding scope. But if I say label is equal to label plus 1, label is the value that we have been passing to this nested function whenever this function has been given a call. So that value will get incremented by 1. So, but if I want to print the variable value of start ka value will be whatever you have passed over here. State ka value will be whatever start ka value is plus 1. That's the value in print. So nothing special about this. So let me just run this code once to see what happens. Or let's debug this code once to see what happens. Nothing special as of now. We haven't done anything special as of now. We give a call to this tester function where I passed value 0. Watch it. Here we go. The start's value is currently 0. So state becomes 1. Look at this. Start is 0. So state becomes 1. Global value is high. Now, in this function, we don't have any variable called as global variable. Sorry, I should have traced this. I mistakenly step over. I went to go inside. State ka value now becomes 1. Look at this. State is 1. Start is 0. Global value is high. I go into this particular function. I'm saying return nested. Now, when I say return nested, this nested function will now be returned. So when this nested function is returned, that is what we are going to print. So if I want to print that, it says it's a nested function. This is the function that is there. Now I give a call to this nested function where I pass value 9. The value of label will now be 9. Watch it. Value of label will now be 9. Can you see that? Value of label is now 9. So label is equal to label plus 1. 9 plus 1 now becomes 10. And I print label, state, start, and global value. Look at this. State is 1, start is 0, and your global value is high. Whatever were the initial values that you had. And then when we come out, that's it. That ran this code successfully. So I'm running the code. It gives you 10, 1, 0 high. 10 is the label. So when you pass 9, 9 plus 1 becomes 10. The label is 10. 1 is your state, because when you pass 0, 0 plus 1 becomes 1. So state is 1, start is 0, and global value is whatever is the value that we had. But suppose if I try and change the value of the variable of the surrounding environment, I can read, but if I try and change the value of the variable of the surrounding environment, it is generating an error. Watch it. What I'm trying to do is I'm trying to change the value of the variable of the surrounding environment, and it is generating an error. That means the nested function, like what we had done over here, has a permission. This is the nested function. It has been nested inside this function called as multiply by. This function has a permission to read the value of the variable of the surrounding environment. But if I try and change the value of the variable of the surrounding environment, that too would have generated error. If I had said factor is equal to 1 or factor is equal to 1, that would immediately generate an error. That means when we have such nested function, it can read the value of the variable of the surrounding environment. It cannot change the value. The moment I'm trying to change the value of the variables of the surrounding environment, it is generating an error. What error does it generate? It says unbound local error. It says unbound. Let's read that error carefully. It says cannot access local variable state where it is not associated with the value. So it says where it's not associated with value. Oh, we have this variable state. It's associated with the value. Still, it is generating error even when I'm trying to access the variable over here. It's generating an error because you are making an attempt to change its value. What if I change the value of the global variable? Okay, so that's also generating an error. What's an error is generating? Let's run this code and see. We saw for local variable, now it says same error. That means you're trying to access a variable and you're also trying to change this value. That's not allowed. But had I written the statement earlier, then there is no error. Then this global variable ka value will become by instead of high. But once I come out and if I print the global variable once again over here, let's see. Hello? I'm trying to access the value of this variable called as global variable. What error it generates? GLB underscore var. We have this variable called as GLB underscore var, and I'm trying to access that variable. Okay, what mistake I had done? I probably had said GBL. Now, if I run this particular program, it says global variable high. And we had changed the value of the global variable to by. Look at this, it had printed by, and now it's still printing high. That means first I'm printing this value. I'm changing, I have already changed the value. So global variable's value has got printed as by. But when I come outside the function and if I check the value of the global variable, it should have been by. But that's not happening. That's because this is no longer the global variable, it's the local variable that has got created. Remember that concept. If you try and assign a value to a global variable, here, global variable inside a function, it actually creates a new local variable inside the function. If I wanted to tell that use this global variable, see this output here, inside the function it was by, and outside the function it is still high. That means the global variable has not got changed. But if I use this statement called as global that we had seen earlier, then the story will be different. At both the places, we will get by. That means we are saying, oh, use the same global variable over here. So that was by using concept of global. Correct? So likewise, this particular function, nested function, has a permission to access the state of the variable of the surrounding environment. But if you're trying to change the value of the variable of the surrounding environment, it's generating an error. Can we do something about it? Let's try. I have a global variable called as GLB where we have a variable called as state. Both of them are global variables. Huh? I have a function called as tester that has a local variable start, that has a local variable state. Not this global, local variable state. What is the value of start that we pass? That is assigned to state, and then value of state is being incremented by 1. Okay. So this state variable is local to this function. It is not this global variable. Since we are not saying global, it will create a new local variable called a state inside this function. Then I have this nested function in which I'm printing label, state, start, global var. And I'm trying to change the value of the local variable. Okay, variable of the surrounding environment. The moment I try and do that, that should generate an error. Look at this. It is generating an error. Local state not defined in the enclosing scope. That means in this scope, there is no variable defined as state. The variable of the surrounding environment, which you are trying to access over here, you can read its value, but you are not allowed to alter the value of the variable of the surrounding environment. You cannot alter the value. And if I want to alter the value of the variable of the surrounding environment and do not want to face this error, okay, do not want to face this error, in that case, I can declare the variable as non-local. Moment I say non-local, I'm telling the compiler, interpreter, don't worry about this variable state, whose values I'm trying to change over here. This particular variable state is not the one that I have defined in this scope. This variable state is the one that comes from the surrounding environment. Now, in the surrounding environment, the variable state that we have has a value which is one more than the value of start. So if tester coil is 5, state is 6. But if this state was accessed, then it should have said, hi, I am global state. But that's not going to happen. You're going to get the value that you have passed over here. If I'm passing 5, the state is going to be 6. So you're going to have 6, start is going to be 5, and global var is going to be hi, I am global. But how about this state variable? Oh, if I try and access that particular variable separately, that's a different story altogether. If I'm trying to access that particular variable, the story is going to be something different. Okay. Here, this particular variable is local to this function tester. This particular variable is the global variable called a state. That means this variable state is different than this variable state. These are two different variables that we have. This is local to this particular function. But then when I'm accessing this variable state over here, the question is where it will search. Earlier, if I don't declare it as non-local, then it is trying to access the variable of the surrounding environment. But you have permission only to read. You cannot change. So if I don't change, it's going to access the variable of the surrounding environment. So 5 plus 1 is 6, it will access. But if I'm going to alter the value, in that case, I need to declare that variable as non-local. The moment I say non-local, I'm saying, okay, this variable state, whose value I'm altering over here, I'm making it from 6 to 7, is not the one that has been defined inside this function, but it is the one that has been defined in the surrounding scope. Surrounding scope is the outer function, not the one that is there in the global state. This is not the variable that we are talking about. We are talking about the variable in the surrounding environment. That means this is the surrounding environment. So here, if I give a call to this function getting tester, and it is going to return this function called as nested, that will be assigned to this getting. We'll check certain things about it. So I'm going to give a call. I'm going to trace this code from here. I'm going to trace this code from here. And also call this function called as getting. And also call this function called as getting. In the correct way, in the wrong way, both the ways I'll call. So I'm going to give the first call saying getting 1. Okay, let's see now. Let's debug this particular code to see the behavior. We are here at line number 26. We at line number 26, we give a call. We come to this tester. Start value is 5. Note कीजिएगा. We have passed over here 5. So value of start over here is 5. State also becomes 5. Then we are changing the value of this variable, local variable state 5 plus 1 is 6. Then this nested function is being created and that is being returned. Now in this nested function, it remembers the state of the outer variable. The outer variable's value was 6. So you remember the state value is 6 over here. Plus state will become 7 when we call that particular function. Watch it. Here we go. We return and I give a call to this getting function. I pass 1. Now when I'm passing 1 to this getting function, this 1 will now be received over here in this label. Watch it. 1 is now received in this label. 1 is received in this label and it prints label as 1, state as 6, start as 5, and hi, I am global. So this is still a global variable. Now to understand this even further, what I could do is I could uncomment this statement so that you'll understand this. And let me get rid of this statement that we have over here. Now, let's debug from here to understand the behavior. So the tester function is already created. Variable state, these are two global variables that we have. Hi, I am global, I am global state, I am global, I am global state. These are two global variables that we have already created. But when I give a call to this getting, if I pass first, the first will be received in this label. Let's see. So label now becomes first. Okay. But the non-local state is the one that we had already passed. 5 plus 1 is 6. Look at that. 5 plus 1 is 6. Global variable still hi, I am global. In this scope, you cannot see hi, I am global state. Look at that. That's not there in the memory. That's not in the current scope. So if I come into this function, I print the value. It says first, that's my label. It says 6, that's the state of the surrounding variable. It says 5, that's the state of the surrounding environment. That's your start variable. And then hi, I am global is the global variable. But then it's not accessing this variable state over here. And I say state is equal to state plus 1. So state from 6 now becomes 7. And I return. Next time when I give a call, that's the second call to this getting function. It remembers the state of the global variable, the variable of the surrounding scope. So now, since I had said non-local, the state value had become 7. So label is second, state is now 7, start is still 5, global value is the same. That's not going to change. So when you print this particular value, look at that. It has now become 7. The rest all things are exactly the same. The rest all things are same. Instead of 6, what we have now is 7. When I give the third call, state equals state plus 1. Now state becomes 8. Huh? When I give a third call to the nested function, because that's the one that was returned and assigned to this, there is a closure. Okay, there's a closure. So I'm trying to access it. State coil is now 8. That means whenever inside this local nested function, I'm trying to access this variable, it is not accessing the global variable state because I said non-local. That means I'm telling, don't search for this variable inside this function. Don't search for this variable in the global scope. Search for this particular variable in the surrounding scope. But suppose in the surrounding scope, you did not have this variable and you are declared as non-local. Let's see what would happen. You are declared as non-local. And unfortunately, there is no variable in the surrounding scope. Okay, there's no variable in the surrounding scope. Then what would happen? If I want to run this particular code, in that case, it generates an error. That means if I declare it as non-local, it is necessity that there has to be variable in the surrounding scope with the same name. Okay. So I'm just sharing this particular code for a moment before we discuss a few more things about closure. Just give me a second, we will continue. Am I visible? Okay, just started. Okay, so let's continue with our discussion. So that was about the concept of non-local. If there's any question that anybody has about this concept of non-local, please ask before we proceed. Have you understood what this concept of non-local is? We already know global, we knew local. So today we are seeing non-local. Non-local means it is not local to this function. It is not global. It is in the surrounding scope. That is non-local. And I have seen only Python language where we come across this concept of non-local. We always have local and global variables in all the languages or many of the languages. And here we have a non-local. That means it's not local variable, neither global variable, but the variable defined in the surrounding scope. That's non-local. That's non-local. Any questions?
सर वो सिर्फ राइट परमिशन के लिए नॉन
quick feedback.
सर
Quick feedback, everybody. Have you understood this concept of non-local?
हेलो
Viraj, I cannot hear you.
हेलो
Yes, sir.
सर वो सिर्फ राइट परमिशन के लिए ही नॉन लोकल यूज करना पड़ेगा ना?
Two things. For right permission, we could have made it global as well. We are saying if I'm trying to read access this variable, which copy of that variable should be used? First, the right permission tha. Second is don't create a new local variable, because if I say right permission, it will actually create a variable. Look at this. If I want to give you a right permission, I don't have to bother. Huh? So if I don't declare as non-local, and if I change the variable's value, right permission change dena hai, de do. It will not generate any error. But state is equal to state plus 1 means I am also reading and updating. So read करने के लिए variable should already be there, ना? तो ये 5 है, तो 5 plus 1 will now become 6. Correct? So right permission, if I do it this way, it will become a local variable. But I want to say, okay, I want to access this variable over here, whose value I'm going to read and write. So this state is equal to state plus 1 is as good as writing state is equal to state plus 1. So there is no problem while I'm reading this variable. But there's a problem while you're trying to assign. Because if I'm reading and if I'm assigning, so if I have only assigning 1 to it, then there is no problem. It will create a new local variable. Correct? But you're first using that variable and then you're creating it. It will say, no, that's not possible. So here it is generating error. It's saying, I do not have any local variable called a state. Can you see that? It says local variable state is defined in the influence scope on line number 14 before assignment. So if I could write this statement earlier, then there is no problem. Then it's a new local variable that would get created. But when I'm writing this particular variable over here, you're trying to read a value of a local variable after it has before it has been created. That means you're creating a local variable on line number 21 and you're trying to access the value of the local variable on line number 19. How can you access something before its creation? So that's not possible. Here I say state plus 1. Now, if I say state plus 1 over here, that's now generating error over here. Why? Because here, if you are trying to read a value, that's okay. You can read the value of the variable of the surrounding scope as well. This one you can read, but you're trying to assign. That means it has to be a local variable, and local variable here it says local state defined in the influence scope and number. So that means it says On line number 14, you have defined a variable. You are trying to change the value of the local variable of the surrounding scope. Then, and you cannot read its value before it assign a value to it. It is generating an error. But if I want to do that, declare this variable as non-local, saying this variable state is no longer local to this function, but it's the one that is coming from the surrounding scope, not the one that has been defined globally, In such cases, we go in for this concept of non-local. It was not just about assignment, it was about, okay, let me explain you one more term. Later, we are going to come across something called as MRO. Okay, but before even I come with MRO, let me tell you, there is a order in which search happens when you refer to any identifier. Whenever you refer to any identifier, it will always search for the identifier. It can be variable name, it can be function name, whatever it is, within its own scope. If it doesn't find, then the enclosing scope. If it doesn't find over there, then in the global scope. So you're saying, stop the search. Don't search for that identifier in the local scope. Don't search for the identifier in the global scope. In between, you can search. That means outside the inner function in which it has been accessed, and inside some outer function. Now it can be nested within nested also. That means inside A I have B, inside B I have C, and inside C I have D. And in D, if I say non-local, it will search in ABC, all the functions, but not in the global scope. So non-local means not within its own scope, but also not global, somewhere in between. That's non-local. Have you understood this? Prithviraj, Viraj, Monica?
Yes, sir.
Monica, what's the problem? Okay.
No, sir.
Now, if you really want to explore this closure, what we could do is, I'll jump over here now. We already have these gettings. And if I say gettings.closure, that's another magical attribute that is there. So I'm saying getting is this nested function, that's a closure. I'm saying dot closure. So when I say closure, what does it give me? So it gives me something cell integer object, cell integer object. That means there are two integer objects. Ek integer object here hai, another integer object is over here. Okay, cell integer object. So there are two statements. It says cell. Look at this. Cell at so and so, integer object, cell at so and so, another integer object. What are these? So when I say closure is when the inner function, the outer function returns the inner function. Correct? And the inner function is accessing the variables of the surrounding function. That's closure. So for this nested function, which has now been returned over here, this is the closure. So it tells you in the closure, which all variables of the surrounding environment are you accessing. So these are two variables of the surrounding environment that you're accessing inside. So this closure is about those two variables. But then how do I know what those variables are? Oh, we can check it out. If I say getting.closure of 0, so in that case, we'll give the first variable. It says it's a cell. Okay. It says it's a cell. So closure was a tuple. Okay, sorry. If I just said getting.closure, it gave me the these two values, cell at so and so, cell at so and so. If I say what's the type, it says it's a tuple. And tuple के अंदर जो पहला element है ये क्या है? So it's of type cell. So I got the types. And cell के अंदर content क्या है? I can get the content as well. Okay, if I see the content, it says content is of type integer. Okay, so closure gives you a tuple. So this was a tuple. Can you note this? Round brackets. So this was a tuple. Inside the tuple, the first element is the cell. Second element is also cell. Okay. And what is the content of that cell? Content of the cell is integer. That means the cell contains integer. I want to see the value of start and stop. So I can say closure of 0 dot cell content. So I will not say type now. I'll just see the content. If I want to see the content, I got value 5. That value 5 is the one that we have passed from here. That is assigned to the start. And the start was having value 5. State becomes 6. Okay. And this label 6 it changed to also 7 and 8. It had changed. So here, when I'm accessing this start, what it had printed is value 5. So that's value 5. Let's see the content. If I now see the value of content, it says 9. How did I get this 9? Oh, I got this 9 because earlier it was 6. then it became 7, then 8, and then 9. Remember when we called it 3 times, every time we change the value of the variable state. So it is 9. Now, I want to see how many variables of the surrounding environment I'm accessing. So there are 2 variables. So getting refers to the function written by tester, that is nested function. How many variables of the surrounding environment is it accessing? Well, just get the length of that particular closure. It says 2 variables of the surrounding variable it is accessing. I say getting of hello. This time around, when I say getting of hello, we are going to give a call once again. Label is hello, but state will now from 9 become 10. Let's do it. Here we come. And we print it, we return from here, and we print the content. So cell 0 content 5 rahega, but cell 1 ka content will now be 10. I give one more call. Again, we come inside. All the values are printed. 10, 5, hi, I am global. But this 10 will now become 11. It becomes 11. So if I print cell content 0, it's still 5. But closure of 1, it will now be 11. It is now 11. So we can access, we can at any point, the function is aware what are the variables of the surrounding environment. This function is aware what are the variables of the surrounding environment. This surrounding environment is it accessing. And to know which are the variables of the surrounding environment we are accessing, you can call closure that gives you a tuple, or you can check for the length of that particular tuple, like somewhere we are done. So it'll tell you how many elements are there. You could access the variable, it will give you cell, but what's the content of the cell? It will tell you the integer, character, what are the contents of the cell. So the 2 variables that we have here, state and start, the state and start, for this function, they are the variables of the surrounding environment. If any time using the closure, you want to know which are the variables of the surrounding environment whose values are which are being accessed inside that nested function. In that case, you can call closure. And closure will give access to the values of the variables of the surrounding environment that we are trying to access. Have you understood this? Closure will give an opportunity to access the values of the variables of the surrounding environment which are being accessed inside the nested function, or inside that nested function, or inside the closure. So that was about closures. I'll be sharing some more additional examples for you to just go through it. And that will help you understand this concept even better. But when you look at those examples, it's your duty to make sure that you trace the code and see. Not just read or not just run. Only when you trace the code, you'll understand. Trace the code, you'll understand how really it works. So tracing is something which is, debugging is something which is very, very important. That will give you better understanding as to what is happening. So I'm sharing some additional examples with you all. I'm sharing some additional examples. I've commented out the things in a proper way. Till now, our outer function has written only one function. Now it could happen the outer function returns more than one function. What would happen? So let me just take one more example for you. I have a function called as tester, which has one nested function, another function called as foo. That means, or I could give the name as nested 1 and nested 2. A nested 1 hai, and this is nested 2. So both of them are nested functions, correct? Inside this nested one, I'm declaring state as non-local. That means access the variable state from here. Okay. And value of state, I have to just say +1. Value of state is one more than the value of start, suppose. One more than the value of start. So label will be whatever label you pass. State will be whatever is the, we are given start and end both we are given. And end is also what we are trying to access. So what is the start state? One more than the start plus end it will give you. And state coil is going to increment by 1. What? Oh, I'm incrementing, so let me not increment over here. State coil is going to increment by 1. Now here, I'm trying to return two functions, nested 1 and nested 2. Let us say nested 1 and nested 2 are two functions that we have written. Nested 2 are two functions that we're going to return. So when I give a call to this tester function with two values, 5 and 10, if I start, 10 is stop or end. But then if I see the type, what does it print? That's something we should focus on. So let's debug this code. And when you see what's the type of the value that it has returned, okay. Oh, I should say print type. I just forgot. There's a print type. What's the type of the thing that it has returned? So let's run the code once again. If I print it, it says, oh, it's of type tuple. Okay. So when I'm giving a call, it says there's some tuple that we are getting. So now I give a call to this tester once again. First call has already been given. So this was the first call, 5 and 10. So 5 was received over here, 10 was received over here. Correct? And it returned you nested 1 and nested 2. That's a tuple that is returned. Ye jo nested 1, nested 2 hai, that is a tuple that is returned. And want to check that, we can do it. This type is tuple, or I'll assign two variable. I'm going to call. I want to know what's the type of the result. We'll say it's a tuple. Result, it's a tuple. And I want to see what's there in that tuple. First element, second element. That also we could do. That was the type. I would like to see the contents of that particular tuple. So it's going to return two functions, nested 1 and nested 2. The result of 0 is nested 1, result of 1 is nested 2, because when I give a call to this particular function, it returns two functions, nested 1 and nested 2. So that is what it should probably print. I'll stop here. And let's see what it prints. Can you see? Function nested 1 and function nested 2. Content, right? Okay, type क्या था, tuple था. Content में क्या है? First nested function and another nested function at whatever address that is there. Okay, so that was about what it returns. So likewise, if I say TT is equal to tester 50,109. So 50 and 109 will be passed over here. Here, label will be whatever you pass when you give a call to this tester. TT when you call. Okay. If I call TT. Okay. But now it's going to return two functions. One is nested one and nested two. So there are two different functions that we're going to return. So this TT is referring to a tuple of these two functions. And if I have to call nested one, or if I have to call nested two, what I'll have to do is I'll have to say TT of 0 that will call nested one. That's a function that will get called. And suppose if I decide to print it, or it's already printing. Okay. And if I say print TT of 1, if I call that function. So if I call this 0, I'll have to pass some label also. That's my label that I'm passing. Let's see what will happen. I give a call. It says nested one check. It should have printed the values. Let's stop debugging over here and see what value it prints. Let me comment out the rest of the statements. We're just interested in knowing what values it prints over here. Look at this. Nested one check 50109. How did that happen? Label is nested one check. 50 is the start. 109 is stop. 109. 50 start. 109 is stop. Stop or end. What is the value? So when I say TT of 0, TT of 0 is referring to nested one. That is the function that is getting it called. Inside this function, we are printing three values. So we are printing three values. We are printing three values. Let's see. It says check. Okay. It says nested check. Nested check जो आपने ये pass किया है. Then 50 and then 109. So this is nested check 50 and 109. But after that state one has changed. Huh? After the state one has changed. So it will remember the state of the surrounding variable of the surrounding environment. Now when I give a call over here, it says 51. Why 51? The state from 50 had changed to 51. So when I give a call to this nested 2, it gets the updated state, that is a 51, not the state of the variable over here, not the state of the variable in the global environment, but the variable state from the surrounding environment. So one nested function making changes has affected another function as well. Okay. So I'm saying TT of 1. Why am I saying TT of 1? Because TT of 0 is nested 1, TT of 1 is nested 2. So when I say TT of 0, it is as good as calling nested 1. And when I say TT of 1, it will call nested 2. Look at this. Now, this is 1 and 2. It's a tuple. Na? Nested 2. Okay. You want to check the name of those functions? That was also possible. Okay. If tester returns 2 function, it's a tuple, you can unpack it. I can say F1, and this I can call it as F2 is equal to this TT. Now this TT is nothing but what this tester has written. It's a tuple. So that tuple is unpacked. So F1 will now become nested 1, F2 will now become nested 2. Okay. And if I want to print them, I could either print it. I could say F1.name and F2.name. F1.name will be nested 1, F2.name will be nested 2. I can call F1 with some value. Hello, if I pass, it will print hello. And what is the value of state and end that will print? End is definitely 109. State is whatever is updated value after we have given calls. If I give a call to F2 function once again, F2 function, F1 function once again. Yeah, if I now give a call to F2 function, F2 will call nested 2, which returns the state. Okay, updated state, which returns the updated state. If I del tester, so even if the outer function is destroyed, the inner function still exists. So even after that, I can actually give a call to F1 of hello, and I can actually call F2 of hello. So even after, so I'll just say here, is destroyed. The you still remember the state of the non-local variable. So even if I delete this tester, if I call F1 hello F2, it'll give the values, whatever the values are. Okay, so if I run this, it should not generate any error. But every time value of start state is changing 51, 52, 53, it's still allowing you to access. So here what we are access is 53. Here what we are access was 52, what it is. And somewhere over here we had access value is 50, 50, 51. So 51, 52, 53, it's all updating every time. All things possible. So we can get the name of f1.name and f2.name. Can you see this? Nested 1, nested 2. So I could write some statement over here for you to recollect, understand. क्या से written हुआ है. So tester is the nested function, correct? First function written by tester 1 is nested 1. Second function written by tester is nested 2. Nested 1 or nested 2, दो function written करें. So we can have एक example, one function returning two inner functions, and both of them are examples of closure. Why? Because the inner function is accessing the variable of the surrounding environment. Here also the inner function is accessing the variable of the surrounding environment, and both of them are returned. So it's still a closure. So closure occurs when the nested function accesses the variable of the surrounding environment and the nested function is returned. That is when closure occurs. What was the nested function? We can find out. Inner function कौन से थे? Can you see this nested 1, nested 2? Okay, we can find out. We can see the contents inside it. So for contents, we just saw one example. By using this closure attribute, we can see what are the contents inside it. All things are possible. So I'll share this fifth file once again with you. If there's any questions in whatever we have discussed already, once I delete it, then I cannot call this function tester. Surrounding variable function is destroyed. But I can very well call F1, I can very well call F2, the two nested 1 and nested 2, I can very well call them. That's perfectly okay. This is printed by nested 1, this is printed by nested 2. That's perfectly all right. So have you understood the concept of closure? I'm sharing this fifth file once again, since we made a lot of changes to the file. Changes in terms of, just to understand, I've added some comments. Code I have not changed much. Have you understood this? Yes, no? Just below. Monica, what's it out? Okay, so let's understand few more terms which are related to whatever we have just now discussed. You may come across one more term called as factory function. The factory functions are sometimes used by programs that need to generate event handlers on fly in response to conditions at runtime. We haven't yet come across such kind of requirement. Event handler, when I click my button, what is to be done? When I click left button of the mouse, what is to be done? When I click right button of the mouse, what is to be done? That response as to what is to be done is nothing but you can say a handler that will handle that particular situation. The factory functions are sometimes the program that needs to generate event handlers on the fly. That means this function is not already created. When you call some function, you will get another function. That could happen. A function that creates and returns another function with information that may vary per function made. So as the name says, it's a factory. What do you mean by factory? What do you get out of a factory? You get some products outside a factory. So if I have a factory function, that means it's a function which will create functions. It's a function which will create functions. It's a function which will give you functions. So it's a factory of functions. So we call it as factory functions. Factory function gets its own set of state information. So every time you call that factory, it'll give you another instance of the inner function. So it's a factory function. So what we have seen was a factory because it is returning you functions. Closure we just now saw. All function objects have closure tuple attribute, closure tuple attribute that returns cell object if it is a closure. So if it's a closure, this will give you a tuple. And what's a closure? Closure is nothing but we have a function within a function. The inner function accesses the variable of the surrounding environment, and the inner function is returned. That becomes a closure. So if there is a closure, then only we'll get this tuple. Closure attribute returns a tuple of cell objects which contains details of the variables defined in the enclosing scope. That means the closure attribute will give you information about the variables of the surrounding environment which are being accessed inside the nested function. Okay, the closure attribute of a function will give you information about the variables of the enclosing function which are being accessed inside that local function in nested function. So we have seen some attributes. Okay, so I think let me just add a bit of animation to it. It's already there. So okay, so let's start once again. Function attribute are user-defined names attached to functions directly. When you attach user-defined attribute to a nested function generated by enclosing factory function, they can also serve as per call multiple copy and writable state, just like non-local scope closure of a class attribute. Function attributes allows the state to be accessed outside the nested function. With non-local, the state of the variable can be seen directly within the nested definition. So what is it? When you attach user-defined attributes to a nested function generated by enclosing factory, so if I have a closure and if I plan to attach some user-defined attributes, they can also serve as per call multiple copy and writable state, just like non-local scope closure and call attributes. So before we jump ahead with that very important topic called as decorators, let's talk about this. If I try and change what will happen. If I have an example to talk about it, let me just see. Here we go. Let's understand. Oh, but let me now, what do I need to do? Let's define these two functions. Let's just rewrite this code in a slightly better way. Understand. Now we are seeing some basic attributes. There is something more. I have a function foo, which has a documentation comment like it's me foo, and it prints the statement saying inside foo, and it returns nothing. It returns nothing. Return nothing. I have a function called as tester, which is a closure. Why? Because it has a function called as nested that is accessing the variable of the surrounding environment. Okay, I'm saying nested.state. Okay. Now when I say nested.state, it is in the enclosing scope. Okay, enclosing matlab is surrounding state ka variable. Change attribute, not the state itself, but the surrounding environment. Okay, so let's trace this particular code. We are not trying to access the variable directly. If I try and access the variable directly, it will generate an error. What I'm doing instead, I'm saying nested ke andar ka state ka value is incremented. But where do we get the state inside the nested? I'm getting it from this tester function. Okay, nested in the enclosing scope, not within its own thing, but it has derived it from the enclosing scope. So that's value also I'm going to change. Let's look at some attributes. When I debug this particular code, there is this function foo, there is this particular function foo, which does these two operations, but I'm adding an attribute to a function, adding some additional information to a function. If I say foo.name, I'll get the name of the function, that is foo. If I say foo.doc, that will give me this documentation comment that's saying it's my foo, it's me foo. If I say foo.age, I'll get this age. Point is, you can add attributes even to functions. Point is, you can add attributes even to functions. Let's do it. Foo.age. Where are we? We are here. Let's debug and jump over here and see what happens. I say foo.age. It gives me 8. Where did this value 8 come from? 8 was nothing but this value 8, which was assigned to this particular variable age, which is now binded with this variable from name called as foo. So foo is a function. Normally it has attribute like name, doc. The name is the name of the function. Doc is this documentation comment. Doc is the documentation comment. But you can add any other attribute. So I'm adding an attribute called as foo.age equal to 8. The moment I add such an attribute, okay, it's an attribute that has now been added. So let's rearrange the code. Here, if I add this particular attribute to that function, so in addition to name and doc, it will have one more piece of information associated with it, that is age. Yeah, date of writing. When was this the function created? I could do that. Okay, and when I say foo.age, it will give this value 8 that we are just now seeing over here. So let me run this code once again. Okay, let us run this code till here once again. So if I'm at foo.age, and if I try and access this foo.age, it gives me value 8. Now I give a call to this tester once again. This time I pass value 0. So if I pass 0, start will be 0. So, and state value will be one more than the previous value. Last time the state was how much had we passed? So when I'm giving this call, I haven't given a call to this function tester till now. So when I give a call to this tester with value 0, tester will have value 0. This state will also have value 0, and this will increment the value of that particular variable state to from 0 to 1. So when I give the second call, I'll get value 1. But when I give the first call, I'll get value as 0. Okay. So that was the first and the second call that we have given. So what we could do is we are anyway printing it. Okay. F is equal to tester. When I give this nested function will get called, it will print. Ham, it will also print. So let's see what values get printed. The first time it is 0, then it is span. So when I pass span, value of start is 0 because you are passing from here 0. But here I'm incrementing it. The value has now become 1. Value has now become 1. When I give the second call, it again comes here, prints the label that is ham. But look, value of nested car state is 1. And 1 plus I say state is equal to start once again. So I shouldn't say start. Start ka value was whatever value that we have passed 0. So let me change this. Let me say nested.state plus 1. Nested.state plus 1. And then I come out of that particular function. Oh, here I have done. I already done. Let this be what it was here. This statement I could write here. I could write over here. That would, if I write over here, nested.state is equal to start, it is generating an error. But if I say state is equal to start, in that case, it will create a new local variable called a state. But when I write this particular statement over here, when I write this statement over here, it means the variable state that is now binded to this function called as nested its value is supposed to set to value of start. The state call is already being incremented. Okay. Initial function. So when we give a call to this tester, that time this will happen. Okay, check it out. In all subsequent calls, that statement won't get executed. Watch it. Huh? Let's do it from here. So I run the first statement. I got foo. Doc kya hai? It says it's me foo. It's me foo. Age we binded more. That is 8. Foo.age will give you 8. Okay, so we got 8 till here. Now I give a second call saying if you go test of 0. That's the first call, test of 0. So when I give call test of 0, start value is 0. Label ka value you haven't yet called that particular label. The label will be called over here. Whereas when I say tester, it will return you this nested function, return you this nested function. But when this nested function returns, state ka value has already been incremented by 1. Okay, why? State ka value is already incremented by 1. But here it was start ka value is 0. So 0 plus 1 will now become 1. Okay, so we need to check that thing out. So if I give a call, watch it, we come here, we execute these statements. where say nested.state is equal to start. तो ये nested के अंदर का जो state है, its value is start. Start का value 0 है, तो its value will now be 0. Let's see. It is 0. I return this nested. I come back. I give the first call to this nested function, wherein the value of state is what it was earlier. State का value था 0, तो यहाँ 0 ही है क्या 1 है? Let's check it out. We go inside. We execute the instructions. It says 0. Why? Because when this was created, value of state was 0. After that, we had changed the value of that variable state. Oh, value of state over here was 0. But when you say state is equal to state plus 1, 0 plus 1 had to become 1. But when you say nested or state is equal to 0, that means this inside this function, this variable state, okay, that is defined inside this function, it's not a non-local variable. It's a local variable for this particular function. So there are two ways in which you can define a local variable. You could say local and state. And here when I'm saying nested.state, that means the variable which is present inside this nested, its value is now set to start. So state actually has been incrementing the value. So if you check for this particular variable state, अगर state का initial value 0 था तो ये 1 हो चुका है local variable. But the moment you say state is equal to start, it will always store value as 0. It will store value as 0. So even during the second call, you got ham and 1. Now how did I get 1? Okay, because inside this, the value of the variable has been already changed from 0 to 1. So as many number of times you call this, now if I say f.state, it will give me value 1 once again. Oh, it has given value 2. Why? Because that's the second call. In the second call, the state value again got incremented. Means you can have a variable that has been defined, but this particular variable is the one. Which variable is it? Here I'm reading its value, and here I'm changing its value. Okay, so now this is a attribute that is now being binded to this function. So nested is in the inclusive scope. Change attribute, not the nested itself. So I'm saying nested.state is equal to state plus 1. The big question is, what is nested.state? Here I'm binding this attribute to that thing. The initial first, this is called I'm binding. Now, where did this concept of binding come in? We took the last example. There was a concept of binding. How it was binded. Where is that function attribute gone? Oh, here. This was the first example. Then I said foo.age equal to 8. So foo is a function to which we have binded this attribute called as age. Likewise, nested is a function to which we are binding an attribute called as state. Note, state has not been defined anywhere earlier, but to this nested function we are assigning. But can we first access the variable before it has been created? No. So in the surrounding environment, we are creating that binding. So here what is happening is binding initial state after the function defined. I'll call it over here as that is what we need to understand. It's binding the attribute. So it's saying there is a function called as nested, which has been defined. It has a new attribute called as state, whose value is start. Start value is 0 hai. So once this tester was called for the first time, here on line number 32, the value of state has now become 0. But when I call f, that is the inner function, the 0 plus 1 will now become 1. But here, it will give you value as 0. But after 0, it has now become 1. It has now become 1. Okay, it has become 1. So when I give a call, its value is already 1. So if I print this, if I give a call to this spam for the first time, let's debug from here and see what happens. Here we are. This concept we had seen earlier. So let's directly jump over here. When I give f is equal to tester, so we come here. We are inside. It'll create a new variable called a state, which is binded to this function called as nested. It's a new variable that is not of the local, neither global, nothing. It's just a new variable. Like we could bind over here. Now we are binding it over here. Its value start value is 0 because the nested or state का value 0 ही आएगा. दोनों value 0. I return such a nested function. So when I return, f is pointing to the copy of the nested function in which value of state is 0. In which value of state is 0. Mark my word. So when we come here, we access it. So we say spam and 0. Spam is the label and nested or state is 0. But 0 plus 1 becomes 1 now. It has now become 1. When I give a second call to the function nested, I pass ham. So when I pass ham will get printed, but nested or state value 2 ban chuka tha. So that is what it will access. Let's see. We come inside. 1 ban chuka tha. First it was 0, now it has become 1. And now here it will become 2. It will become 2, it comes out. If I check this value of nested or state, we give value as 2. A value 2 aa chuka hai. Sorry. Okay, let me first explain you what I'm trying to show over here. Here, what I'm trying to explain you is I can bind an attribute to a nested function inside the outer function. Note in this, there is no global, no local, no non-local, nothing. So what is the state? Oh, it's a local variable that I binded over here. Initial state after function is being defined. So when you call this function tester for the first time, okay, when we call this particular function tester for the first time on line number 32, this variable is now binded with this nested function with the value of start. Start value is 0. When I give a call to spam, we are calling this nested function. So label ka value is spam, nested or state ka value is 0. But 0 now becomes 1. So when I give the second call, here it will print as ham, but values is now from 0 it will become 1. So from 1 it will become it will print 1. After printing 1 it will become 2. So when I say f dot state, it will give me value 2. So that's precisely what's going to happen. First it was 0, then it was 1, and then it is printed value 2. So point is, you can bind a variable. You can bind a variable to a function in such fashion. The function name dot some variable is equal to start. So this becomes the attribute of this function. So you can bind any such attribute at any time to a function. So that was about binding attribute to a function. Here also for function foo, we are binding this attribute to this function. So let me write over here. What am I doing? I am binding an attribute that's age to the function foo. Okay, here I'm binding this attribute state to this function nested. So you can bind this attribute anytime. And you want to say, okay, that's attribute that I'm trying to access. Okay, so just say the function name dot state. That's an attribute that I'm trying to access. F dot state is nothing but nested dot state. So this particular attribute can be accessed inside the function. The attribute can be accessed outside the function as well. So that was all about function attributes. So you can create an attribute, bind it to the function with whatever values you would like to bind. So as long as that function is there, this attribute will remain. If the function is destroyed, then that attribute will also get destroyed. Attribute is like property of that function. You define a function, you thought, this function should have some more information. You can just bind. So their value will remain binded with that particular function for a long time. Okay, until you do not delete that particular value, it will remain with that particular function. So it's like supplying a one additional value to that particular function is binding. And inside the nested function, I'm accessing that binded value. When I say foo.age, when I'm saying foo.age, so in that case, with this nested function, there is this attribute age that has now been binded. So I'm trying to access it, I'll get it. Likewise, over here, when I say test of 0, with this state value 0 is being binded. But when I give the first call, what happens is it prints 0, but it becomes 1. When I give the second call, it prints 1, it will print 1, but it will become 2. And when I say f.state, it will give value as 2. And that's precisely what's happening. It printed 0 first, it printed 1, and last it printed value as 2. So the point to make is, first part is this. You can bind an attribute to a function. That means you can attach some additional information to that particular function. First thing. Even if it's a closure, we can still bind an attribute to any function. So when I say nested.state is equal to start, the value of start has been assigned to the state, and that's the same variable that we are accessing over here inside the nested function. So we can refer to the attribute of the nested function inside outer function as well. Function attribute is a defined names attached to function directly. We can refer to the nested function attribute in the so we have accessed that variable here. We also access the variable over here. In the main scope, we can refer to the nested functions attribute in the nested function. Okay, we can bind the attribute in the enclosing function, and we can access it outside as well. So that was all about this concept of closure. You'll come across some very important use cases for closure later, but this is what closures are all about. Any questions so far?
Sir, why we did not put dunder before age?
Somebody is asking some question.
Sir, we did not use dunders before age. And after
I
that,
I could add dunder also. It's our choice. That's not a difficulty. But then it has a different meaning in Python. I have not yet told you. So I could just say foo.age, and I could add something more. I could just say foo.date is equal to आज का डेट है. Rana, I use dunder. आगे.
yes, sir.
डेट टाइम का क्या करना एक था ना. Let's see the attributes. Input date time, dir date time, we had date, date time dot date, तो year डाल देते हैं 2023, month and day 26. Okay. Yeah, per date. So we can access it. So there is no problem in using underscore. We can use underscore as well. Is that okay? Viraj?
Yes, sir.
But it has a different meaning. Huh? I have not yet told you the reason when to use underscore, not to use. It will not create any difference even if I use underscore. But it has a different meaning actually. If I use underscore, those who have done object-oriented languages, you had learned something called as private variables and public variables and protected variables. Anybody knows that? Anybody is aware about public, private, protected?
Yes, sir.
It's about private. That means it's private to that particular function. But in Python, it doesn't enforce privateness. But a lot of times, if I use underscore, I'm trying to tell to the other developer that I plan to keep this information private to this function, which should not be accessed globally. So unless you want to tell to somebody that let this information be private, don't use underscore. Because if I use underscore, somebody will try and assume that you're trying to keep it private. So that's what happens. Private means that piece of information is accessible only inside the function or outside the function. So avoid adding dunder to things which you want to access publicly. If I want to hide it, then we'll add underscore and do all the necessary stuff to hide that particular thing. Currently, we are not hiding. I should avoid using underscore. Is that okay?
Yes, sir.
I'll share the files once again since we made some changes to these files. I'm sharing all the examples of closure once again, since there are some changes that we have made. Okay. Don't get this. Take the last set of functions that I'm taking because what Viraj asked, that change is not reflected here right now. I'm sharing the examples once again. The third time, I'm sharing. Last set of examples are the one that you should now refer to. So that was about all about the concept of closure that we had to discuss. So I've taken closure and function attributes. Tomorrow in meet, we are going to talk about function decorators. As the name says, what decorators are. So tomorrow's topic will revolve around concept of decorators. Any question as far as today's session goes? I'll stop here today because decorators will take some time. I do not want to take half thing over here and half thing tomorrow. That's not something that I'd like to do. We will again discuss about decorators tomorrow, and that will be all about our concept of function, which did extend for a very long time. Any questions, anybody? No? So with that note, we'll stop here today. See you tomorrow at same time. We'll discuss decorators, another very powerful concept. So we've seen three very powerful concepts: generators, closures, and decorators. Decorators you'll find very interesting. So we see tomorrow what is this concept of decorators. So when I use the word decoration, what comes to your mind? Oh, doing something, adding something to something. So that's decorator. We'll do some fantastic work tomorrow. I'll show you some applications also for decorators when we meet tomorrow. Our objective here is not to go in for use cases. We're just trying to understand the concept. Later in the course, we'll be having use cases where I'll use these features. But for that, whatever are the syntactical features that we should be clear of. Then when we start using it, there should not be confusion. How did this happen? For that, I'm just building the foundation where I'm trying to make you understand the concepts. Later, we'll see the use cases. So with that note, we'll stop here today. See you tomorrow. Take care. Love you all. Bye-bye.